You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Hello, and welcome to another on-the-road episode of the New Stack Makers. I'm your host, Heather Joslin, editor-in-chief of the New Stack, and today we're on the road at JupyterCon in San Diego. And our guest today made some news yesterday. He is Jakob Jurových. He is founder and CEO of Deepnote. And yesterday he announced that Deepnote is going open source. So welcome, Jakob.
Yeah, thank you. Thanks for having me.
Thank you for joining us. Can you tell us a little bit about Deepnote and what it does?
Yeah, so Deepnote fundamentally is a data notebook. We started out back in 2019, so working on this for about 6 or 7 years. And during this time, we saw that there is a need for a new kind of computational medium. Mm-hmm. This is our background. We started out building developer tools, but we also want to figure out ways how to share those technical pieces mm-hmm. of work with more or less technical audience. Mm-hmm. And for a long time, we struggled with this exact problem because we had like these two worlds that we could choose from. Mm-hmm. World A was the world of tools that were simple to use, easy to get started with, but they also were limiting in a certain sense. Mm-hmm. Like we call this low barrier to entry, but also it has like fairly low ceiling. Mm-hmm. The tools such as spreadsheets, for example, mm-hmm. It's very easy to get started with spreadsheets. Spreadsheets are amazing. There's just so many people who know how to intuitively work with spreadsheets, mm-hmm. but there is a limit of what you can do. Mm-hmm. On the other hand, you have this world B, where tools are much more advanced. Let's say code editors, IDEs. We can say the sky is the limit. You can just build anything that you want, mm-hmm. Anything that you can imagine. But you also have to spend quite a significant amount of time to understand, okay, what is a terminal? Like, how do I pip install pandas? How do I print hello world? Yeah. Let alone trying to actually build some application. Mm-hmm. So we were missing this computational medium that could bridge these two worlds. Mm-hmm. And we came across this idea of notebooks, which is actually quite an old idea. Mm-hmm. It's been around since the 80s. Back in this, like one of the AI summers, like when people actually were trying to figure out, okay, like how do we build tools that can bridge the gap between humans and AI. Mm-hmm. So all the ideas of around literature programming from a long time ago, or Mathematica was actually one of the first notebooks out there. Mm-hmm. But there was never a good time for this format. When Jupyter came along, we actually got very excited mm-hmm. because we felt like, okay, here we are. Like it's happening. Like we are seeing that the time for notebooks came. Mm-hmm. And we tried to work on this. There were some things that we liked about Jupyter, and we could build on that. Mm-hmm. But there are also things that we were missing. So eventually, that led us to 2019, where we decided to start to work on Deepnote, mm-hmm. which was this notebook reimagined for, at the time for collaboration. Mm-hmm. And right now, it very nicely transitioned into this, let's call it AI era, mm-hmm. where we are working not alongside other human collaborators, mm-hmm. but also alongside many AI agents.
The timings certainly can't be beat.
Yeah, definitely.
It's definitely an era that will require mm-hmm. tools like this. What were some of the challenges, like as you're building Deepnote, that you had to overcome, or you had to mm-hmm. figure out to get to the stage it's at now?
Mm-hmm. There are definitely many technical challenges that mm-hmm. we can go into. But I would actually start with some of the philosophical challenges first. Okay. Because that was the real reason why we started out Deepnote as a separate company. Mm-hmm. Back then, in 2019, collaboration wasn't yet a thing. Mm-hmm. You could collaborate in Google Docs. There were tools such as, let's say, Figma coming out, and you could suddenly see multiple designers coming mm-hmm. in the same place. But when it came to, let's say, software engineering and developers, there was almost like, very strong anti-sentiment towards collaboration. Mm. There was a very strong feeling that the collaboration should be happening asynchronously, that I am using my own code editor, and I'm using it locally. And the moment I want to collaborate with someone, I'm going to prepare a very nice, a very polished pull request. I'm going to send it over to GitHub, GitLab, any of the of these systems, and someone's going to leave a review asynchronously. But we also were coming from this world of data exploration, and we understood that that's not how data analysts, data scientists operate. Because when you're a software engineer, the path is certainly difficult, but it's also pretty clear. Like in the morning, I wake up and I have a bunch of Jira tickets, linear issues ready for me, and I know what needs to be done. Like I know what the end state looks like. And I can just go and work on this, and eventually someone's going to review my work. When you are a data analyst, data scientist, if you want to do some data exploration, the task is more like, well, here is a CSV file, here is just a bunch of data, and go ahead and try to find something interesting. I'm going to get tasks such as, well, train this model on this data, but we don't know whether it's even possible in the first place. Like, is there enough of the data in there? Like, are there some patterns that we can actually discover, or just going to be too messy? And we simply don't know. So the need for collaboration is just fundamentally different. In software engineering, you can easily go for hours without talking to anyone. While in data exploration, you're like maybe like 5 minutes in, like, well, I run this like 5 queries. This is interesting. And by the way, like I'm getting a bunch of nulls in this database. Why is that? So you have to have this much tighter feedback loop around collaboration. And it just so happens that even tools from that software engineering workspace or like workflows where every single chunk of work that I do has a nice commit message, it just doesn't exist in data exploration. My commits are like, I tried something number 1, I tried something number 2, commit ABC, because I simply don't know when I'm done with my exploration. There's always a possibility to go deeper or wider.
So the philosophical
exactly
were the big challenges first.
So we had to go and essentially just convince people that collaboration is even a good idea in the first place, and you probably want a tool that is built for collaboration in mind. We just couldn't really rely on plain old Git, even though that's what we grew up on. It just wasn't sufficient for those tight, fast iteration loops that we required. After that, it started to become much easier because we built the first examples of real-time collaboration. We started to show how there can be not just 2-3 people kind of like pair programming in one notebook, but having hundreds of people. Like let's say early on, like we have seen like Deepnote broke because one day there was like 300 people like in the same document and they just didn't understand like what is happening. And it turns out it was like 9 a.m. Some class started somewhere in Asia, and it was like one professor typing in something and 300 students observing in the same document. Like, okay, this collaboration is real thing. It's on a much higher scale, much bigger scale than we expected. And now we are routinely having sessions with thousands of people in one notebook.
So scaling it was one big technical challenge. How did you solve for that?
So the technical challenge, that's where it really started. Once people got hooked on collaboration, we had to figure out what is actually even the correct way how to build these collaboration algorithms. There are different ways how to go about it. And at the time there was a big discussion about these collaboration algorithms, CRDTs versus OTs. And we ended up going with OTs because it was, it was 2019. Like CRDTs wasn't quite there yet, and we want to make sure that we are building on something stable. This was also the collaboration that we were used to from Google Docs, which was at the time probably the most advanced collaborative experience. And we had to build a lot of infrastructure because this is fundamentally stateful. And we need to have a server that is able to coordinate multiple clients. We went a couple of iterations of that. We had to build quite a few extensions to editors because the place where we are typing code it still has to understand this diffing format and apply the patches in the correct order. And if there are, the amount of line endings bugs that we had to sort through was insane. But over time, we believe that we found a pretty nice architecture. We are actually able to simplify it pretty significantly. Now we are running in a system that is actually fully stateless, and it supports very nice and intuitive collaboration.
Great. And so we mentioned the announcement that was made to make Deepnote open source. How was that decision made?
So this was a decision that it feels like we made like a long time ago. We really want to be open source from day one. Like it's the environment that we are coming from, and we are definitely building on top of lots of open standards. It just felt right. But we are also a business, and we need to build a product that solves the pain points of our users. And very early on, we came to our users and said, hey, we know about these 10 different problems that keep popping up whenever you're working with notebooks. Please rank them by priority. And as you can imagine, stability was like number one. And if you can still solve stability, if you can solve reproducibility, if you can solve collaboration, like those are the real tangible problems, and open source is then just cherry on top. So we were like, okay, fine, let's just go first and solve these problems. And we also, very openly, we just weren't sure like whether the architecture that we are building on is the right one right from the beginning. We definitely made a couple of iterations. We definitely made a few breaking changes along the process. So it helped us save some time, not having to build everything in open and just essentially being committed to lifetime of backwards compatibility. But now, a couple of years later, we got through these problems one by one, and we also got to a point that we are very confident about our architecture. We are very just given enough time in the space, we feel like we understand the constraints, we understand the needs for what the notebook for the next decade should look like. So we are quite confident to just go out there and say, hey, this is the open standard. This is something that we are committed to supporting for a very long time. And obviously there are going to be revisions moving forward, but none of them we don't expect any like major revisions where you have to, start complete from scratch from blank canvas.
The last few years have seen a bit of churn in the open source space. You've seen companies take formerly open source projects back behind more restrictive licensing, for example. We've seen some forks like OpenTofu, for example, and of Terraform. And what from a business standpoint, what is the thinking about going open source?
For us, so first of all, open source is tough. We all know this coming from the open source background. It's just difficult to sustain. So unless there is a meaningful business model behind open source, it's going to be very difficult for the open source projects to survive. And open source projects very rarely go and die. There is always someone who fixes a bug here and there. There is always some level of activity. But quite often what happens is that the level of activity is just simply not enough. The world is moving faster, the market is moving faster, and if there is a closed format that is able to keep up with the market, it's just eventually going to win, even though the alternative format is open source. For us, we got to a point that we were for a long time building on top of IPNB as an open standard, which was surprisingly very well designed right there from the beginning. I don't know how those guys did it, but they somehow nailed it, and they were able to, back in 2011, design a format that is still with us here today. But as we were building Deepnote, we got to a point where we started to abuse this format a little bit. There's this field called metadata where you can put pretty much anything.
Yeah.
And at some point, the notebooks that we created was full of metadata and very rarely of the actual content that the format was intended for. And it's just like a very, very quick example. When it comes to Jupyter, Jupyter is based on two types of cells, code cells and markdown cells. In Deepnote, there is no such thing as cells. Like we just call it blocks, as in building blocks. There is at the moment 23 of them, and we expect to add many more. So trying to figure out how can we map this to those two original ideas of markdown and code. It just didn't really just got to a point that we really had to do some acrobatics to put it in there. So that was the original. It was kind of like the final straw that made us yes, we are confident. We know what we are building. The world needs a new format. We need a new format, something that would be actually fit for, let's call it, the next decade. Especially as we have to understand that the format that we are originally building up on, this was designed pre-cloud, essentially, pre-collaboration, pre-AI, and a lot of these concepts just don't easily translate into what was there before.
What do you see as? I mean, obviously we're at JupyterCon. It's a whole the whole ecosystem built on the original Jupyter notebook. What do you foresee as how the ecosystem ideally could grow around the concept of Jupyter notebooks, and products, like yours?
Yeah. So notebooks by itself, I just love the category. We love it so much. We started out. There are some initial ideas. Obviously Jupyter was by far the biggest one, but we have seen a lot of really interesting experiments come along the way. There are people who are developing new types of kernels that were reactive. So today in Jupyter, you have to pretty much run every cell manually. It doesn't exist in spreadsheets, for example. Spreadsheets, everything is automatically recalculated. You just don't even have to think about it. For most users, they don't think about some computational engine behind spreadsheet. Even though it's one of the most important, impressive pieces of software written, somehow it's able to be this performant at this scale. But after lots of experiments, we got to a point that we really see notebook as a perfect user interface for working alongside AI agents. We have seen it early with chat interface, where you kind of go in and you ask a question and you get the answer back, and eventually you had to do a couple of round trips of questions answers. But you also inevitably end up with some kind of artifacts on the side. Let's say you want to write a document. So we are chatting with an agent, and the agent is producing your legal paperwork, let's say, or you are chatting with an agent and it's writing React application. This was definitely out of scope of that original chat interface. But when we're looking at notebooks, what we saw is that there is this concept of input and output. There is this concept of collaboration, and it just mapped so nicely. And eventually what you are going to be building in the notebook. Today, most people imagine notebooks more as a data exploration tool, kind of like a scratchpad, where you go in, you do some quick calculations, and then you move on to do the actual production work somewhere else. What we see in notebooks is a beautiful format where you can actually stay and keep in the same place all the way to productionizing your workflow. For example, you can start with quick messy SQL queries to figure out what is in your warehouse. You write some simple pipelines, but eventually the notebook itself can become the whole data app. It can become that thing that you schedule to run every 12 hours. It can have an API endpoint attached to it, so you can call it externally and get the results from it. So having a notebook that is not just a scratchpad, but also the full medium that can be the host of those production-ready artifacts that I believe is the future of notebooks.
Okay, and I think that's a good place to wrap up. Thank you very much. Thank you very much to Jakob Jurových of Deepnote. Thanks for joining us.
Yeah, thanks
today.
for having me.
And I want to thank all of you for joining us for this conversation. And this is Heather Joslin for the New Stack Makers on the road to JupyterCon. We'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.